So, hello everyone. Welcome to day 52 of Learning Data Science. And we have covered the theory part of first moment, business decision, second moment, third moment, fourth moment, fifth moment. Okay. We have covered all those things. Right now, what we are going to do, we are going to practically im- uh, implement those. Okay. And we have also covered with practically implementing. We are in the stage of outliers treatment. EDA is basically completed. Data pre-processing also, the outlier treatment, the basics completed, right? So the only part left is we will just discuss about the practical implementations of outliers treatment. Then we will just discuss about some standardization, normalization, encoding, these all stuffs. So approximately after 3 to 4 days, okay, for 4 to 5 days, my EDA will be completed. Oh, sorry, data pre-processing will be completed with feature engineering as well. So we will then start with SQL, and then it will be Power BI, then machine learning. Okay. So basically it's long way to go. Just now it's 52 days, but yes, we have covered many things. So we will start with the steps. Okay. So first, as I say always, you have to just download Spider. Why Spider? Because again, it's a beginner friendly approach. But again, in my other YouTube videos, which is the recent video, AI research assistant. Okay. So in that, I haven't used Spider. I've used VS Code because I personally am suitable to VS Code. But yes, as a beginner, I would suggest Spider. Okay. Because it has various implementations. Okay. So first, what I will do, I will just open a new file here. Okay. And here I will import certain libraries. Okay. So for example, I will import pandas. Why pandas? Pandas help in data manipulation. Okay. Next, what I will do, I will import NumPy. Why NumPy? Because it helps in numerical calculation. Okay. So these two libraries we will be talking about. Okay. And also I will import Seaborn as SNS. Again, why Seaborn? Helps in advanced visualizations. Okay. So these many libraries I have imported. Now what I will do, I will use here df and I will write pd dot read. Basically, I have some issues with my keyboard. Some of the keys doesn't work properly. Okay. pd dot read csv, and I will give the path of my particular CSV file. Okay, so let's take a CSV file. This Walmart. Okay, I will simply copy as path and I will use here read string and I will paste it. Now let's try running it. Sorry, my bad. Import pandas as pd and import numpy as np. So I will execute this. Okay. And in the variable explorer, if we will go and if I will click on this data frame, so you can see what all things are there here. The date is there, weekly sales is there, temperature is there, fuel price. Okay. So basically this holiday flag, this is my categorical data. Why this is in string? Again, if you have to see the details of it, so what you will do, you will just write here df.info function. And df.info basically what it does, df.info basically it gives the information into including the data types as well. Okay. So it will give you the information including the data types as well. So you can see here wherever you can see the object I'm writing, wherever you are seeing object as D type, it means it is a categorical data. Categorical data which is string. Okay. For that reason, I will just show you why it is a string. You can see here my date, it is in string, holiday flag, and company. This is string. So for that reason, now what I will do, I will use a box plot, sns dot box plot in weekly sales, df dot, or I can write. So basically, what's the functionality of box plot? I have told you the primary function is to see the outliers. Okay, so if I will go into my plots and if I want to see basically what is my sales status here. So it's taking some time. No, it's not happening. SNS, import matplot lib dot pyplot or plt. Let me plot the histogram plt dot hist and file is just. Oof. Okay, there is some issues with that. Okay, I will just save my file. I will just save my file as data processing. First, excuse me with my spelling error. Okay, and if I will restart my file because sometimes file crashes. Okay, I will restart it. so that the box plot and the visualization could be seen. Okay. Okay. And if I will execute all this line of code, and if I will go here in plots, basically you can't see anything here. So to show you the plot, let me open VS Code. My as usual, new file, Python file, or we can do new file and new file. I will open Jupyter notebook over here. Okay. I will open Jupyter notebook so that I can see the visualization more accurately. Okay. I will just cut it. I will do shift enter. Okay. And if I want to see the visualization, I will just execute this kind of code. And if I will run it, SNS, sure, I don't know why it's not happening. Basically, let me see my dear and let me execute it. Let me execute. This why it's taking time. Okay, wait. Basically, it was some plotting our to select existing Jupyter server or stick and stick. Okay, so basically I have to execute this line of code. Yeah, so it's executing. Okay, I'll execute this. You can see here, now we are getting, basically, I needed to select my kernel, and what was happening due to my floating video controls in my Zoom, these things were showing. I wasn't able to see it, basically what it was trying to show me. Okay, so you can see here my outliers are here, and if I will rotate my screen like this, if it's screen like this, if I will scroll it, then you can see it is in my maximum range. The outliers, the bubbles, this is max, this is min, this is q1, this is q2, sorry, this is q1, this is q2, this is q3, and this is my max, this is my min, and my outliers are in the maximum. So what skewed data it will be there? What is the skewness of it? Obviously it is maximum, so it is greater than zero. Yes, you are right, it will be right skewed. Okay, so if I will execute it, then you can definitely see it. My data, it started from here like this, and it is right skewed. You can see the skewness here. It is right skewed, my data. Okay. And if you want to find the correlation also, then how you can find the correlation? So DF, what was there? Basically, what we are looking for, we are looking for weekly sales, right? So weekly sales, I will write dot CORR, correlation. If I will try to find, then obviously you will see it will be greater than one. You know, it's not here. Dot. Yeah, so correlation with respect to temperature is this. Again, if I want to see what if I want to see the skewness of it. Sorry, my bad. I was speaking about skewness and I told about correlation. Okay. So if I want to see the skewness, so definitely you can see here, it is my 0.6, which is greater than 0. So whenever my skewness value will be greater than 0, so it will be right skewed, as we have discussed. So with the graph also we are seeing it, and with the help of skewness also we are seeing it, that it is right skewed, right? So we are getting that my outliers contain, my data contain outliers. So what I will do, I will use my detection using the interquartile range. Okay, I will use using IQR. Again, what is IQR? You can see here. If I will press the tab, outliers data points that are more than 1.5 away from the IQR. Q1, which I've already decided, explained you guys in the box plot, that my IQR, it is Q3 minus Q1. So how I will write it in my code? Okay. So I will just mark down this particular line, this particular cell. I will just try executing. Okay. So how to write it? IQR is equal, IQR equal to BF. I'll write here salaries. Sorry, weekly sales, weekly sales dot quantile, which is 0.75. You can see here why it is 0.75, because Q3 75% of data is there for that reason. Now if I will execute this, so what we have done, we have successfully detected the outliers in the series column using interquartile range. And if I'll write here print IQR, okay, and if I'll execute this line of code, then you can see here my outliers value is this. Okay. And if I want to calculate the lower limit and upper limit, so how can we calculate it, the lower limit and upper limit? The same way which I have told you guys, the lower limit, lower boundary and upper boundary, how it is there. Again, it will not contain space, which is DF, and within DF salaries dot quantile, my bad, dot quantile 0.25, 0.25, minus what will it will be there, IQR into 1.5. IQR, if you are not able to understand these things, then you can certainly go and watch my theory video. You'll definitely get it. Why I'm writing these things. Okay. And again, here it will be 0.75 plus IQR. And if I will just print it, print lower boundary, and what I will do, upper boundary, upper boundary. And if I will execute this line of code, okay, and if I will execute this line of code, then what is the error? I've done the same thing, but I don't know why it is not applicable. Sometimes it's just the problem with your ID. So no need to worry with that. We're on the right step. Okay. So if I will do here, and if I will execute this line of code, then what's it? Key error salaries. Sorry, my bad. Sorry, yeah. Basically, this wasn't the salary, this was weekly sales. This was basically weekly sales. And if I will execute this, you can see my lower boundary and upper boundary got created, right? So now what I will do, I will try removing this outlier, or what we can do, we will just try removing it. First is the 3R technique which we use, remove outliers. Okay, we will remove outlier and let's trim the data set. Okay, and we are using the trimming technique. And what we are doing, trimming technique is used to remove the outliers from the data set. And let's flag, let's flag the outliers in the data set. Let's flag the outliers. So what we'll be doing here, we'll be writing here df1. Okay, df1, and I will write here np dot where function. I'm comparing it where df dot weekly sales is greater than my upper boundary, then what it will do, it will just use true, and np dot where if my df dot weekly sales is less than lower boundary, then it's true. Otherwise, the whole thing will be false. Otherwise, the whole thing will be false. So if I will execute this, so if I will print my df1 here, if I will try printing df1, okay, then you would see that false, 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 false. Basically, the outliers wherever it is there. And again, if I have to presently find where my outliers are, so what I will do, I will use here df out, and here I will use ilog function, and I will log the value where till my df1, sorry, df1. Okay, and I will print df out. Okay, so now let's execute it. So you can see here You can see here, these are my outliers. These are my outliers. Basically, we are going to see the outliers are there. These are my basically the outliers. How we have come to a conclusion of this? Basically, what just be focused here, what we did, we calculated the box plot. We have seen my maximum outliers were there, and using my interquartile range upper boundary, I have found, I have assigned a column, df1 is there, okay, one data set is there, df1 column, and where I put in the values, wherever my weekly cells will be greater than upper boundary, then it will be true, otherwise it will be false, and whether it's less than lower boundary, then it will be false. The same way the where we used to detect the outliers. Do you remember how we can find the outliers value, outliers value, if it's minimum, outliers value, if it is minimum, then what we were doing? Do you remember? In terms of minimum, we were just subtracting these values, which is, you can say, here, yeah, which is Q3 minus, sorry, Q1, Q1 minus 1.5 times of UPR, and outlier value, if it is max, then Q3 plus 1.5 times of IQR. And we have done the same thing here. And then we are checking it. If my weekly sales value is greater than upper boundary, it's greater than upper boundary, then obviously if it's greater, my upper boundary, which is max, my upper boundary, which is max, then obviously it is outlier, then it will return true. And if it's false, then obviously it's outlier, then it will return true, otherwise false. So here you can see it. Okay. And basically what we have done here, df.log. So df.log, basically what's the basic behind it? The basic behind the log function is that log function basically works as, you can say, the slicing, which I've taught in string. So basically it is slicing wherever my df1 column is there. And again, it can take the very first value, it's row. It can take like this, the value is like this. It can take, but again, I want only my df1, and again, I have to write here comma. Okay, sorry, my bad. I have to write here comma because this is the rows. It will take the rows where my false is there, and every column it will take, not one column. This is basically rows, and that is basically all the columns. Okay, so here you can see it. It have taken all the values. Basically, how my log function works. How my log function works. Let me explain it. Okay, basically log function, what it does in here, the very first we will write the columns. Sorry, my bad. We write the rows, and then we write the columns. Okay, so here my rows is there, and here my columns are there. For that reason, I have written here rows and columns. So I think you have understood it. So tomorrow, when we will come, right now I will save this file. I will save this file, and I will use uh, the same way, and the save type will be Python py dot and Python, and I will write here data preprocessing, data preprocessing. I will write here. I will save this file, and tomorrow we will execute. Okay, I have to basically say we are on in IPNB, IPYNB. There's data pre-processing. Okay, so I've saved this file, and tomorrow we will start with the same. It's like we will start with deleting these outliers, filtering this, and we will exclude this. Then we will start with the winsorization. Basically the replace. Now we are trimming it. Now we will replace the values. Also, we will see that. Then winsorization, and then we will understand fit and transform. What is basically fit transform? So these all things are there to learn. So till then, you guys just keep practicing it. Take any data set from Kaggle and try implementing the pre-processing techniques. So tomorrow, till then, goodbye. Take care. Keep practicing. Jai Hind.